Good afternoon, everyone. My name is Shakir Mia, and today I'll be presenting my project title, Woman's Safety Device with GPS Tracking and Emergency Alert System. So this project focuses on the application of embedded systems technology to enhance personal safety and address real-world social challenges. So first, I'll be speaking about the introduction. Women's safety has become a serious concern due to the increasing number of incidents of harassment and assault. In many emergency situations, victims are unable to make phone calls or seek help immediately. To address this issue, my project presents an Arduino-based women's safety device designed to send real-time emergency alerts along with GPS location information. The device is portable, simple, and reliable, ensuring that it can be used effectively even under stress. Overall, this demonstrates how physical computing and embedded systems can be applied to solve real-world social problems. So the project overview. So the main objective of this project is to develop a security system that sends an emergency alert when a panic button is pressed. Once activated, the device detects the user's location using a GPS module and transmits this information via SMS through a GSM module to predefined emergency contacts. Since the system operates wirelessly and independently of a mobile phone, it remains functional even if the user's phone is switched off or the battery is depleted. The next slide is about the target audience. So the primary audience for this device includes women of various ages between 15 and 55 years old who face safety risks while commuting or working alone. It is also beneficial for female students traveling alone and working women who work late shifts. Parents and guardians also represent a secondary audience, gaining peace of mind knowing their family members can quickly signal for help. So the next slide I'll be talking about is the problem statement. So in emergency situations, victims are often unable to answer phone calls, make calls, or safely report their location. High levels of stress and anxiety can significantly slow response time, whilst internet-based solutions may fail in low bandwidth or no network environments. This project addresses these challenges by providing a simple one-button user interface that enables fast and reliable emergency alerts without relying on continuous internet connectivity. So the design process. The design process began with identifying the key security challenges currently faced in the country. I analyzed various existing solutions, including software-based applications and IoT-enabled systems. Based on this analysis, I selected an embedded system approach due to its reliability, simplicity, and independence from smartphones. Technical modules were then developed to demonstrate the core features with a focus on portability, energy efficiency, and affordability. So the system architecture. The system is controlled by Arduino Nano, which serves as the main processing unit. A GPS module is used to obtain accurate real-time location information, while a GSM module is responsible for sending emergency alerts via SMS text. The system is activated using a panic button and a buzzer, and also a LED, which provides immediate audio and visual feedback to the user. This modular architecture makes the device easy to troubleshoot, maintain, and extend in the future. So the next slide is about the hardware components. So the first one is an Arduino Nano function as the main microcontroller, a Neo 6M GPS module which provides real-time location data, a SIM800L GSM module which is used for SMS-based emergency communication, a panic button which is included to trigger the alert, along with a buzzer and LED for immediate feedback. And also finally the system, which is powered by a battery-based power supply enabling portable and reliable operations. So the software, tools, and programming. For the software, the Arduino IDE was used to write, compile, and upload the program using C, C++. I utilized the Tiny GPS library to process and interpret GPS data and the software serial library to enable communication between the Arduino and the modules. So the system was developed using a step-by-step testing approach with sequential reviews carried out to troubleshoot issues. So the next slide is about implementation. So regarding implementation, all components were assembled on a breadboard with proper connections. The GPS module continuously calculates the user location, while the GSM module stands by transmit alerts. When the panic button is pressed, an SMS containing a Google Maps location link, which is then sent to the predefined contracts, and the buzzer and LED are activated to provide confirmation. So there's a flowchart here, a diagram. So we can look at the system design. The Arduino Nano acts as the brain of the system at the center. So it reads inputs from the button and GPS processes the data, and then sends commands to the outputs. And peripherals include the GPS module. This communicates with satellites to determine real-time latitude and longitude. The panic button, which this signals the Arduino to start the emergency alert sequence. The GSM module, which then sends the SMS alerts to predefined contacts. The buzzer and LED, these provide loud sound and visual flashing to indicate the device which is normally active. The battery also is the supply. This supplies portable power to the whole system. So the challenges and solutions. So during testing, I faced a few challenges. So the GPS module had to be evaluated in a open environment to ensure accurate detection. So I also encountered a power shortage due to the high demands of the GSM module, which was resolved by using a stable power supply. Any communication issues between the modules were addressed through serial debugging and iterative code improvements. Functionality. So the device is activated with a single push of the panic button. Once it's pressed, it normally sends a real-time SMS alert, and this triggers both audio and visual alarms. This design allows for both remote monitoring and local awareness of the situation. Additionally, the device operates offline, making it reliable in environments where the network connectivity is limited. So the learner outcomes. This project has significantly enhanced my understanding of microcontrollers, serial communication, and integrated programming. It helped me develop important skills including problem solving, system integration, and overall computer programming abilities. So the ethical and social considerations. So user privacy was a key consideration. The device shares location information only with trusted contacts and uses it exclusively for emergency situations. This project demonstrates how technology can be practically applied to solve real-world safety challenges. The future improvements. So in the future, the device could be miniaturized into a wearable form, and voice functionality could be added. Other improvements could include integration with mobile devices and cloud-based tracking for advanced data analysis. So the conclusion. So to conclude, this project demonstrates how technology can be applied to protect women's lives. By integrating GPS, GSM, and microcontroller technology, we developed a reliable emergency alert system. So this highlights the importance of integrated systems in addressing real-world social challenges. These are my references that I've used for this project, and which is linked to the woman's safety device, which I used the Arduino kit for. Thank you for your time, and thank you for listening.